All right, welcome back. Training Module 4.2, Supermini and Mini Application. This is part two, grades and coatings of the Supermini application training. I'm your trainer, Edwin Tunney, Training and Technical Specialist for Horn USA Incorporated. So before we get into the details about grades, I just want to talk about some of the basis behind why you choose one grade or another. So the first is workpiece material. So basically the harder the material, the lower the speed and feed. And then abrasiveness. So the more abrasive a material, the lower the speed. You also have to consider and be aware of the ISO material groups. You'll find those not only from Horn, but throughout the cutting tool industry. So you have P as steel, M is stainless steel, K is iron, N is non-ferrous like aluminum, brass, and copper. S is heat-resistant alloys like titanium or nickel, and H is hard materials like heat-treated steel. The grade really for the Supermini and Mini product lines really are designed for no or few interruptions, pre-machined surfaces, and smaller diameter. So they're designed with those things in mind. Typically, these are finishing or semi-finishing operations and not roughing. Not to say that you can't do some roughing with Supermini tools. You most certainly can, but they're designed with that in mind, without interruptions or scale or those kind of things. Dynamics, stability. So the stability of the operation really plays a role in your parameter selection. Obviously, less stable operations must have lower parameters. And then cutting speed. Cutting speed is the one thing that is limited a lot by the machine spindle. So cutting speeds tend to be lower just because not the limit of the tool, but the limit of the spindle of the machine. So just keep that in mind when planning processes. Priority, generally max tool life. Most often these are high volume type parts, and long life is expected on those. The part restrictions tend to be a little more strict since it's a semi-finishing or a finishing operation. Max speed, high volume production benefits from using the max speed, but in fairness, the quality of the feature is often the priority with many of our end users. Everybody sees these charts, but over the next two slides, I wanted to explain these charts because I think that's a kind of a lost art. But we have these in the Supermini mini catalogs and our turning and our grooving catalogs. So for each grade, you should find guidance on where to use in a specific ISO group. So you just saw that we have P is steel, M is stainless, K is iron, N is non-ferrous, S is heat resistant or high temp alloys, and H is hard materials. So from an overall view, you can see which grades and where to use them. So you can use MG12 in pretty much steel, in stainless, in iron, non-ferrous, heat-resistant alloys, but it's absent here down in hard materials. So in hard materials, we would recommend using cubic boron nitride, CB10 or CB50. So just keep in mind that if you don't see a specific grade on for a ISO material group, it means that it's not recommended for that group. For instance, another example is EG. So EG is one of our newer coating systems, is not in non-ferrous. So it's not a good choice for non-ferrous alloys here according to the ISO chart. Now, getting into the actual sort of understanding the ISO chart and what it means. The first thing to notice is your ISO workpiece classification. So it's usually color coded. So this happens to be steel. The next is the ISO carbide classification. And basically the lower the number, the harder the grade. So if you have a P01 is an extremely hard grade in the P group here. A 40 would be a very tough carbide. So you go from 01 to 40. So you can see the target here in most of these is the P20 substrate, which has a fairly good toughness. You can see all the different grades that use the P20 substrate. So P20 is uncoated carbide, and then we call it a 2 is how we classify it. You'll see that later in this presentation, just how our grades are classified. But you have an AS62, a TN32, a TI22. Those all use the same grade of carbide. What you will notice though is that based on the coating system, so the coating system actually makes the grade, the carbide substrate, it can improve the toughness or the hardness of that and the range of that hardness. So you'll see that a P20 ranges between a 10 and a 30 with respect to toughness. But then if you put an AS60 or an AS coating on it, it ranges from looks like a 5 all the way to a 35. So it's not only substrate, the coating does also add some properties to the grade. You can see here MG12 substrate. You can find that anything that ends in a 5. So TN35, TI25, TA45, TH35. Since they end in 5, that's an MG12 substrate. And then in addition to the classification, the number, you can see that on this side you have toughness and feed rate. So if you have higher SFM needs, you will have lower feed rate because you're going to have a harder carbide. So harder carbide are able to take more cutting speed, but then they're more prone to chipping. Lower SFM can have higher feed rate because they're more ductile, so you can put more pressure on the cutting edge without it chipping. If you look at, I think horn grades are very straightforward. MG12 substrate is used heavily throughout the Supermini and the mini programs. So the MG12 carbide. The 2 and the 3 substrate cover the ISO P group, and P40, the 3 substrate or 3 is very tough. So very tough. So if you have an unstable condition and lower cutting speeds, you could make use of the P40. But by and large, what you're going to see is a 5, what we call a 5 substrate, which is MG12. K10 is used if you have an abrasive material and you need higher hardness. So maybe you're running a little bit higher cutting speed. And to kind of cap this and look at it, this is our part nomenclature for grades and coatings. So you have a 4-digit system here. The T and the H, those I think at one point many years ago they had a design for that, but grades and coatings have expanded so much within horn that I wouldn't really worry about these first 2 digits too much. Those are really horn specific. The last the second to the last and the last digits, that's where I would focus attention. The second to the last digit here, the 3 in the case of TH35, is the approximate thickness of the coating. So it's not exact, but an approximation of the thickness. And the last is the substrate. So P20 is 2, P40 is 3, MG15 is G, MG12 is 5, K10 is 6, KO5 is 7, and then coated Surmet is 8. So you can see from more or less the KO5, as we learned earlier, would be an extremely a 7 substrate, which I haven't seen really used on much, is extremely hard. So that would be very wear resistant, but also prone to chipping. K10 is used some within the mini and super mini systems, but by and large, most of the substrate are 5 substrate, which is MG12. Another question that can come up is the horn coatings are PVD coatings. And what's often not understood about coatings is why not just make it thicker? So if I want it to wear longer, why not just double the thickness? Well, with coating systems, that doesn't really work because if you see my diagram here, for the same cutting edge roundness, so this would be the same hone size on right on the cutting edge as the PVD coating. Just a physical property of PVD coatings is they're under compression. So as your coating gets thicker, the compressive stresses right at the cutting edge get more pronounced. So once you pass a specific thickness, you start to develop enough stress that the coating doesn't adhere well to the cutting edge. So what you'll notice with a lot of the super mini and mini systems, they have a smaller edge prep. So you'll often notice that they have a thinner coating. So just in general, as a detail, when you have smaller edge preps, think of thinner coatings. I've not seen in all my time any system that worked where you had a small edge prep, a very small edge prep, and an extremely thick coating. It's just physically the physics of it are not possible. All right, so next, just some kind of background information about the coating system. So we know with the Super Mini and Mini, the bulk of those are going to be the MG12 substrate or the 5, what we call 5 substrate. But now the coating system. So we offer a lot of different coating systems. Some of them have just sort of developed over time, and some are legacy systems. But TN3, for instance, a TN35 insert, that is tin coated. So titanium nitride coating has been around for very long time, but is still widely used. It's a general purpose, sort of an alternate for machining steels and non-ferrous alloys, stainless and iron. So it's more general purpose. The next generation of coatings were the TH3 coatings or TH35, and those are aluminum titanium nitride. Those are steel, stainless, and iron. Again, still pretty widely used throughout the catalog in our stocking program. The latest generation of coatings are the EG coatings. So there are 2. So you have EG3 and you have EG, this says 55. This could just as easily say 35 because most of the components are that MG12 substrate. But these are both aluminum titanium nitride, and this is a high PIMS coating. So a very advanced coating, very dense. and it also has a tin flash layer on it. So it looks gold, but that's mainly for wear indication. Those are good across the board in steel, stainless, and iron as a stainless and iron as a secondary and alternate. What you should absolutely remember with the Super Mini and Mini program is that the EG3 is for Super Mini, the EG5 is for Mini. We don't put EG5 on Super Mini components or inserts because the coating is too thick for the edge prep that's planned on the Super Mini inserts. So EG3 for Super Mini, EG5 for Mini. Just keep those two in mind. Then the ES1, so you can have an ES15. That's also aluminum titanium nitride. It's good for stainless steels and S group materials. This is a really it's a thin coating, specifically thinking along the lines of Swiss. So very small edge prep, very small parts. Um, then you have HS, so HS3 for not non-ferrous, for heat resistant alloys, excuse me, and hard materials. So HS is a aluminum titanium silica nitride that gives it a copper gray color and also more heat resistance. So it's a higher heat resistance where you have specifically in heat resistant alloys, the coating can accept more of that heat, that operating temperature. The TI2 is titanium carbonitride. It's a really slick coating, so it has minimal adhesion to the material. Your work material doesn't adhere to the cutting edge because of that very lubricious coating. Mainly for steel as an alternate and stainless. Not listed here is also IG35. That's kind of the next generation, and that can be used on stainless steel as well. Last two, DD2 is titanium diboride, and that's for non-ferrous alloys like aluminum, copper, brass, those types of things. And the main objective of this coating is an extremely sharp cutting edge. You can make a very small edge prep and still wrap this coating around it without the compressive stress that you would see with some other coating systems. And Ne2 is tetragonal amorphous carbon. You won't see this in Super Mini and Mini too much, but it is a coating mainly for non-ferrous alloys like aluminum, maybe more abrasive aluminum, as the case may be. All right, that concludes part 2 of our Super Mini application training. Don't forget to hit subscribe to get all the notifications about videos we post on Horn YouTube page. Thanks and have a great day.